So for those of you who missed class when we did arithmetic sequences and series and we're enjoying your time in Wanakita, here we go. So let's start by looking at a couple of sequences of what comes next. So these are obvious, I think, to everybody. So 2, 4, 6, 8, of course 10, 12, 14. So we're adding 2 every time. Not as obvious, the second one, 5, -2, -7. So we're going down, so it's going to be subtracting 7 every time. So in the second one, we're going to go down, so -23, -30, etc. So some things to think about in these two sequences is, what do they start at? So this one starts at 2, and this one starts at 5. But then what do they go up by or go down by? So this one goes up by 2s, and this one goes down by 7 each time. So those are the important features. So we're going to look at that more on the next page. So in a sequence, we can define the general term as Tn equals a plus n minus 1d. So where a is the first term of that sequence, and then d is what you're adding or taking away each time, and you do it n minus 1 times in order to get the nth term. So for instance, this example here, the first term is a equals 3, and the common difference is 2. So our general term then would be Tn equals 3 plus n minus 1 times 2. And I can rewrite that as 3 plus 2n minus 2 equals 1 plus 2n. And then that would be my formula for my general term right here. Let's try a couple more. So for the second one, the first term is a equals 5, and my common difference would be -7. So my Tn would be a, so 5, using the formula above, 5 plus n minus 1 times -7. Simplifying that, I get 5 minus 7n plus 7. So equals 12 minus 7n. So our general term for the second sequence is 12 minus 7n. We'll do one more. The first value is 53. I'm going up by 13 each time. So my general term will be 53 plus n minus 1 times the 13, which equals 53 plus 13n minus 13 equals 13n plus 40. The general term for this one is Tn equals 13n plus 40. Feel free to go to Khan Academy for some practice activities. I would just search up arithmetic sequences, because this link is not active. Here's some problems that you can try in your notes. Good luck. The next thing we're going to look at is arithmetic series. And an arithmetic series is really just a sequence that we put plus signs between. So they were adding up then all the numbers in a particular arithmetic sequence. Two formulas that we looked at in the video of Gauss and stuff were the sum of all the numbers in a particular series is equal to the number of numbers in the series multiplied by the first term plus the last term that you're looking at divided by 2. Alternately, using our a, n, and d, we can find the sum of a particular series by doing n divided by 2, and then inside the brackets 2a plus n minus 1d. Let's try a few. We know the formula is Sn equals n over 2 times 2a plus n minus 1d. So we need to identify what is our n, what is our a, and what is our d in order to figure out the sum of the first 20 terms. So our a is the first term, so a equals 2. Our common difference is 2 because it's going up by 2 for each term. And then finally our n is the 20th term, and we get that from this S20 here. So now I'm going to put these in the formula and solve. So S20 equals n over 2, so 20 over 2, and then 2 times a is 2, plus 19 times 2 as well, because the d is also 2. So following it through, I end up with 10 times 42, or 420. So the sum of the first 20 terms in this sequence is 420. Let's try another one. Looking at this, I see that a equals 5 is my first term. D equals -7, because I'm going down by 7 each time. And n equals 10. I'm put all of those numbers into the formula and find the sum of the first 10 terms. So by using these numbers, a equals 5, d equals -7, and n equals 10, I substitute them into the formula down here. So 10 over 2, 2 times 5 plus 9 times -7 is equal to 5 times 10 minus 63, and finally I get -265. So with this particular series, when I add them all up for 10 terms, I get -265. Your turn. Try these ones in your book. You've got this. Good luck.